Good day, students. Welcome to another episode on School on Air. This is chemistry class for senior secondary school 4. And the topic we are going to look at today is chemical energetics, also called thermodynamics. As we are aware, thermodynamics, we are talking about heat. Heat. How do we measure heat? We know in chemistry, not only in chemistry, in life in particular, heat, many of the processes we do, probably cooking, heat is involved. So some chemical processes, when it comes to chemistry, actually involves absorbing heat from surroundings. Some involves what? Liberating it to surrounding, and that's what we are going to look at today in today's topic. So chemical energetics. Now, the learning objective of this lesson, by the end of this lesson, I expect you to be able to explain that some chemical reactions are accompanied by exothermic or endothermic energy changes. Then also, you should be able to explain the terms enthalpy change of reaction. Also, you should be able to draw an enthalpy profile diagram for exothermic and endothermic reactions. So get your pen and paper and let's start. Okay. Chemical energetics, also called thermodynamics. We have first law of thermodynamics, which states that energy can neither be created nor destroyed, but can be converted from one form to another. I think this is actually related to law of conservation of mass too. So, first law of thermodynamics states that energy can neither be created nor destroyed, but can be converted from one form to another. Now, energy changes in all chemical reactions. All chemical reactions are actually what? Accompanied by some form of energy change. Energy changes always accompany what? Chemical reactions, as far as chemistry is concerned. Now, changes can be obvious. You can see some changes, especially when something, especially burning in particular, combustion, is visible. Then some are not that visible. You may not notice that there is actually energy changes being involved. Now, example of changes that can be obvious is actually coal burning generally. Then the one that can go unnoticed, we have some that can go unnoticed to some of the common reactions we have in chemistry. Now, we have energy can be liberated, as I said earlier, then energy can also be absorbed. If energy is liberated to the surrounding, we call that type of reaction exothermic reaction. If energy is liberated to the surrounding. Then energy can also be absorbed from the surrounding. When energy is absorbed to the surrounding, we have endothermic reaction. Exothermic and endothermic reaction. Now, we move to examples of what are the examples of exothermic reactions? What are the examples of endothermic reactions? For exothermic reactions, we have, for example, all combustion processes. Maybe both combustion of fuel, combustion of any hydrocarbon, anything that involves combustion, we have what they are regarded as exothermic reactions. Then also respiration. That is oxidation of carbohydrates in our body. All living things we actually undergo respiration. So any form of respiration in our body, even cellular respiration, is an example of exothermic reaction. That means it is liberated to the surrounding. Now, we move to endothermic reaction. That is when it is absorbed from the surrounding. The first example I have here is photosynthesis. We are familiar with what photosynthesis is, the process by which plant manufacture its food. Then, the second example is thermal decomposition of calcium carbonate. Calcium carbonate will actually decompose to calcium oxide and carbon 4 oxide. So the thermal decomposition of calcium carbonate is also an endothermic reaction. So these are the common examples of endothermic and exothermic reactions I've given. Now let's move further to how do we measure? We have mentioned heat changes in chemical reaction. How do we actually measure heat change? There is a term we actually use, and the term is called enthalpy, which is denoted as H. We measure it as enthalpy changes, which is denoted as delta H. Now, what is enthalpy itself? It is a measure of heat content of a substance at constant pressure. the measure of its constant. We have been mentioning heat from the beginning of the lecture. Now, how do we measure this heat? The term we use in measuring this heat is enthalpy. Now, you cannot measure the actual enthalpy change of a substance, but you can measure an enthalpy change. That is why it is written as delta H. The symbol behind H is actually delta. It's the Greek alphabet, Latin alphabet. Now, enthalpy change is, for a chemical reaction, is given as mathematically given as the difference between the enthalpy of products and that of the reactant. As you can see on your screen, the enthalpy change of a chemical reaction is the what? The difference between the enthalpy change of the product minus the enthalpy change of the reactant. Now we have the enthalpy diagram. We call it enthalpy diagram. I've mentioned two reactions today. I mentioned exothermic and I mentioned endothermic reaction. Now we first look at what? Exothermic reaction. When do we have this? Is an energy profile diagram, enthalpy profile diagram for exothermic reaction. You can see here we have what? Like a slope going down, a curve going down. You can see the red line showing the delta its change, which is what? The difference between the one for the reactant and the one for the product. The product is actually down on this, the reactant is above. Then you can see that the enthalpy of reactant is greater than that of the product here. If the enthalpy of reactant is greater than that of the product, delta H, which is the enthalpy change, will be negative. The value will be negative. So if the value is negative, if the value of delta H, which is enthalpy, is negative, the reaction is said to be what? Exothermic. So this is an energy profile diagram for exothermic reaction. You can also see EA there, which is the activation energy. That is for the reactant. The energy barrier which reactant must overcome for the product to be formed. So delta H here represents enthalpy change, and when it is measured there, the value is negative. And when the value is negative, the reaction is said to be exothermic. That means the enthalpy change of reactant is greater than that of the product. Don't forget I said earlier that the enthalpy change of reaction is what? The one for the product minus the one for the reactant. In a situation whereby the one for the reactant is greater than that of the product, delta H value will be negative and the reaction will be exothermic. Now let's move to the energy profile diagram for endothermic reaction. You can see in this one, compared to the last one for exothermic, the product, the enthalpy for the product is actually greater than the one for the reactant. And you can see a red line showing the enthalpy change. How do you measure the enthalpy change? The difference between the one for the product and that of the reactant. And here, the one for the product is, the one for the reactant is less than that of the product. Or you say the one of the product is greater, the enthalpy of product is greater than the enthalpy of the reactant. So you can see that the delta H value will be positive. If delta H value is positive, that means the reaction is endothermic. Endothermic. That means it is absorbed. It is absorbed from the surrounding. It is absorbed from the surrounding. And then you see EA again. EA is the activation energy, which is for the reactant. Activation energy is always for the reactant. The energy barrier which the reactant must overcome before the products are formed. Now, we have come to the end of the class. We have come to the end of the class. First, I talked about what? The first law of thermodynamics, which I stated that what? Energy can neither be created nor destroyed, but can be converted from one form to another. Then I also mentioned, I defined how we measure each change of a reactant, of a reaction. How do we measure each change? The one difference between the one for the product minus the one for the reactant. I also make a distinction between what? Exothermic and endothermic processes, endothermic reactions. So with this, I think you have been able to relate what heat energy, you know what heat energy is now. You have knowledge of what heat energy is and how it is measured. And enthalpy change in particular, that is what we use in measuring each change of a chemical reaction. So I have some questions here for you to treat. You take your pen and paper and write it down as I read it to you. So the first one, state the first law of thermodynamics. State the first law of thermodynamics. We said it earlier. Then The second one here, I have distinguish between exothermic process and endothermic process. I think this is also very simple. The third question says, classify the following as exothermic or endothermic process. Burning of methane, that is combustion of methane. Methane is CH4. Then the second one is cellular respiration. Is here exo or endo? The third one, photosynthesis. The fourth, dissolution of detergent in water. I think this is very common for, especially when you use detergent to wash. Just take this, put some detergent into your hand and dip your hand inside water and feel what will happen. Whether it will be, you feel it, or what will happen, just experience what will happen. Then the next question I have, we are asked to take your pen and paper and draw the energy profile diagram for the following processes: exothermic reaction and endothermic. You should be able to identify this when you see them in a reaction. When they give you in a question and they ask you, is this an energy profile diagram for exo or endo? Then the last question I have here, why is delta H value positive? Why is the value always positive for an endothermic reaction? Why is delta H value always positive for an endothermic reaction? I think this answer, I'm expecting a good answer for this, for all these questions I've given you. So we have finally come to the end of the class. See you in the next class. Bye.